was basics, and now we're going to go more into set theory. So in the last lesson, we defined the use of and or and not in mathematics. In this lesson, we'll apply the use of and or. We didn't really do not very much because with the words, it doesn't make a lot of sense. Make sure your phones are away again if they're out. In mathematics, a set can be defined as a collection of distinct objects. For example, the numbers on the faces of a die form a set. So like the numbers 1, 2, 3, 4, 5, and 6 are elements of the set of the faces on a die. Sets are usually denoted by capital letters or by a description inside curly brackets. So that's how we did the curly brackets, right? An object in a set is referred to as an element. So the number 5 is an element of the set of the number of dice. So an element is just like what we listed. Those are all the different numbers. So on a die, the elements would be 1, 2, 3, 4, 5, and 6, right? In the little squiggle brackets. There are 3 general ways of defining a set, listing the elements in the set. So like on the die would be 1, 2, 3, 4, 5, or 6. Or you can give a description. So the natural numbers less than 7 would be the same as 1, 2, 3, 4, 5, and 6, right? Most people like just listing the numbers. Or set builder notation, which is x such that x has to be less than 7 and all the x values are natural. So this just represents these words. Most people just like 1, 2, 3, 4, 5, and 6. Most people would rather not have that version, though, if you were listing the numbers 1 to 100, right? You'd want to use something else because that would take forever. The curly brackets together is read as the set of, just like I was saying. That straight up and down line, this little line here, represents such that. And the little e is a member of or an element of, okay? This is the key thing that everyone says. I give this on a test and everyone's like, I've never seen the little n before. Yes, you have. It's right here. Little n of a. What that means is the number of elements, okay? The number of elements is n of a. So in the set of A, I have the numbers 1, 2, 3, 4, 5, 6. Little n of A just means how many elements are in there. How many of them are there? 1, 2, 3, 4, 5, 6. There's 6 of them in the set A. So it's not an actual number that's in the set per se. It's how many numbers are in that set or how many elements are in that set. So whenever you have a little n in front of the set, you're going to have a number like 10, 2, 7, 8. It's always a positive number because it's how many elements are in it. It could be 0. It means maybe there are no elements in it. Okay? Note that the number 2 belongs to set A, but the number 8 does not belong to set A. To express this, we can say 2 is an element of A, but 8 is not an element of A if we wanted to. We rarely see that, so don't really worry about that. The order of listing the elements in the set doesn't matter. So if you went 1, 2, or 2, 1, it means the same thing, but you'll see it on a test in increasing order most often. So we're going to look at one. Now this is very similar to what we just did. So consider the following sets. Whole numbers less than or equal to 3. So the first thing you want to do is list them, right? What are the whole numbers less than or equal to 3? What do whole numbers start with? What number? 0, because it starts with the whole number, which is 0. 1, 2. Does it include 3? Yes, because it says less than or equal to 3. If it just said less than, we would have just 0, 1, and 2. Then they want the even whole numbers less than 10. Even whole numbers less than 10. 2, 4, 6, 8. 0 is not really even or odd, it's just a neutral. And it's less than 10, so we don't include 10, even though 10 is an even number, right? Because it doesn't say less than or equal to 10. So list the elements in each set. How you would actually do that is you'd go P equals, and then you'd go 0, 1, 2, 3. Q equals 2, 4, 6, 8. And often on a diploma, if they did this even numbers, they'd go even natural numbers so that you're not having to guess is 0 even or not, right? They kind of take out the guessing. So complete the following. N of P. N of P just means how many elements are in P, which means how many different numbers or different elements are in P. 1, 2, 3, 4. There's 4 different elements in P. The number of elements in Q. 1, 2, 3, 4. There's 4 different elements in Q. So that little n just means how many elements there are. Okay? So on the test, I promise you, and I'm hoping I'm wrong, you'll go, what does this little n mean? And I'll say, you should know. And then you'll look at me like, we've never done it before. And I'll be like, remember that day when I had this conversation with you and you said, I told you that you're going to say you've never heard this before. And you'll be like, you're in your head like, no, I wouldn't do that. And you'll be that person. Don't be that person. There's always like 5. It's not even like 1. There's always like a third of the class will be like, I don't know what the n is. You will remember, okay? Little n means element. Even if you don't remember what it is, you remember we had this conversation at least, okay? So write set P using set builder notation. I don't even really care so much about that. Don't worry about that. Okay? But Q we can look at. So Q says, which of the following is set builder notation? Well, we know it's the numbers from that are evens from maybe kind of C. Don't worry about this one either. We'll come back to this. We'll come back to that. Because I just want you to mainly understand the other stuff for now. Okay, flip over. So now we're going to learn some terminology. Because there's actually quite a bit of terminology in this unit. Not where I ask you for the definition of something, just that you need to know what the heck the word means, right? Betty is defining sets using non-negative single-digit numbers. Single digit means like 1, 2, 3. The moment I hit 12, that's a double-digit number. 102, that's a 3-digit number. 1,000, that's a 4-digit number. So Betty is defining sets using non-negative single-digit numbers. So that's the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I'm just choosing to not put the 0. From the list of non-negative single-digit numbers, she defined the following as even numbers. So which of those are even? This is our little universal set. And universal set is often used with the U with the 2 little lines on top, kind of like a horseshoe. And the reason why they do that is the little U without the little lines on top horseshoe means or. It's union. It means or. So if you get a U without those lines, it means or. So universal set needs to be represented by something different. So that's why they do the U with the little ticks, the horseshoe ticks kind of. So the even numbers have to come from the universal set. So 2, 4, 6, and 8. Whole numbers less than 7. So 1, 2, 3, 4, 5, 6, and then I stop. Why didn't I add a 0, even though 0 is a whole number? Because my numbers have to come from my universal set, right? And I told you your universal set are the numbers 1 to 9. Okay? So even though 0 is a whole number, it's not part of the universal set, so I can't include it. Okay? Universal set is the numbers that I'm only allowed to have. Odd numbers less than 7. So 1, 3, 5. I can't include 7. Okay? All right. So we've already went over the universal set. Within the context of any problem in set theory, there generally is some largest set that we have in mind. We refer to this set as the universal set. It is the set that contains all of the elements under consideration and relevant to the problem. So state the universal set. We did it already above. Look above. If you didn't do it above, do it here. Subset comes up a lot. This is another word that everyone forgets about. Subset. A subset of a set is a set that contains some or all or possibly none of the elements from previously defined set. It's represented by this symbol, the sideways kind of looking U. Looks like this. That's subset. It's also written up there as subset and shows you the U. Remember, that's your formula sheet on the left. It's there, subset. The only problem is you'll see the symbol and you'll look on the sheet and you'll say subset, and then you'll be like, but I don't know what a subset is. So what does it matter that that is the word subset? So we need to know what a subset is. So it says here, it's used to represent the relationship between sets. So for example, set E is a subset of set U. That means that all of the elements in E are in U. So if set E is a subset of set U, all of the elements in E have to be in U. And then it's represented by E subset of U. So that means that all of the elements in E have to be found in U. So let's see if that's true. E has the numbers 2, 4, 6, and 8. Are all of these numbers found in U? Yes. Is there more in U? Yeah, that's fine. But in order for E to be a subset of U, everything in E must be in U. So what happened if in E I had 10? What happened if in E I had 2, 4, 6, 8, and 10? Would E be then a subset of U? No, because 10 is not in U. Okay, so the first letter, E, is a subset of U. It means that everything in E has to be in U. So everything in the first letter has to be in the second letter. Does that make sense? That's what a subset is. Is set E a subset of set L? Is set E a subset of set L? Is everything in E found in L? No. E has 2, 4, 6, and 8. L has 2, 4, 6, but not 8. So no. It's not a subset. So E is not a subset of L. That is an E. It does not look like an E, but it's supposed to be one. E is not a subset of L. Okay? Empty set. So that's what a subset is. Empty set. Empty set we did in the last lesson, right? So it means they contain no elements in common. So you have to have and in order for it to be an empty set. So are there any two sets up there that have nothing in common? O and E, right? Nothing in common. E has 2, 4, 6, and 8. O has 1, 3, and 5. So I could say that E and O equal the empty set. The symbol that we use for and, you guys, is an upside down U. It's intersection. So E and O equal the empty set. So instead of saying and, I can use intersection. The reason, the way I remember, one is this way, one is this way. I remember which one's and because if I drew a line in it, I could write and. That's what I do. The other one's or because, well, I don't know. It's not and. There you go. Okay? So if you can write a line and make and, it's an and. This way is or. Okay? So the way you always get the only way you can get an empty set really mainly is by and, right? Because or you list anything in the one or the other, so you're not going to get an empty set for the most part unless one of them is empty. Well, no, then you'd still get it. They'd have to both be empty. Complement of a set. The complement of set A is the set of elements in the universal set that's not in set A. So if you look up here, it has A complement. It's even on here. It's A with a little tick, right? That means the complement of A. That means the complement of what is in A. So everything that's not in A but contained in the universal set. So set A is, the complement of set A is A with a little tick. So if we want the complement of set E, that's E with a little tick. You list everything that's in the universal set that's not in E. It means not E. Complement of E, not E. Okay? So what's in the universal set but not in E? So here's E. Here's the universal set. What's in the universal set but not in E? 1, 3, 5, 7, and 9, it looks like. So 1, 3, 5, 7, and 9 are not in E, but in the universal set. Does that make sense? Yeah? So not in E just means in the universal set, but not in E. Okay, let's look at an example using all of the stuff we learned. Consider the following two sets. A are the natural numbers less than 20 that are divisible by 3, which means you can divide evenly by 3. So, and then B are the natural numbers less than 20 that are divisible by 5. Explain why the set of natural numbers less than 20 is a suitable universal set. Why are the natural numbers less than 20 a suitable universal set? Both A and B only deal with the natural numbers less than 20, right? So that's why. The universal set should be the natural numbers less than 20 because both of them only have it. So the universal set is going to be the natural numbers less than 20. Natural numbers are the natural numbers you count, and you naturally start off with 1 as a little kid. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 10. Yay. We ran out of room. And it says less than 20, right? So I can't include 20. If it said less than or equal to 20, then I would include 20. Now you list what's in the set. So they want to know what's in set A. Set A are the natural numbers less than 20 divisible by 3. So these are the natural numbers less than 20. Which numbers of those are divisible by 3? Which ones of those that can I divide by 3 and get an even number? Like just get a natural number, not a decimal. So 1 divided by 3 is a fraction. 2 divided by 3 is a fraction. 3 divided by 3 is 1. So 3 is divisible by 3. 4 divided by 3 is 1/3, 1.3333. 5 divided by 3 is still a fraction. 6 divided by 3 is 2. So 6 is divisible by 3. 7 isn't, 8 is, 9 is divisible by 3 because you get 3. 10 isn't, 11 isn't, 12 is divisible by 3 because you get 4. 13 isn't, 14 isn't, 15 is because you get 5. And 18 is because you get 6. So those are all the numbers that are divisible by 3, where you get a non-decimal number when you divide by 3. B, all the ones that are divisible by 5. 5, 10, and 15 are the only numbers that you can divide by 5 and get a non-decimal answer. Complement of A or not A. What are the numbers that are in the universal set and not in A? It's going to be quite a few because these are the only ones that are in A. So 1, 2, 3 is in A, 4, 5, 6 is in A, 7, 8, 9 is in A, 10, 11, 12 is in A, 13, 14, 15 is in A, 16, 17, 18 is in A, and then 19. Write a description of the elements in the complement of set B. The complement of set B. So if B are the ones that are divisible by 5, not B would be the numbers that, what? Divisible by 5. What's the opposite? So instead of saying they are divisible by 5, we're going to say the numbers that aren't divisible by 5. The natural numbers less than 20 that aren't divisible by 5. So C are the natural numbers less than 20 that are multiples of 6. Multiples of 6 start off at 6. So we'd have 6, then 6 more, so 12, then 6 more, 18, and then we're done. That's all that there is because we're natural numbers less than 20, right? So which of the following are true? Are they true or false? Is C a subset of A? Is everything in C in A? Here's C, here's A. Is everything in C in A? 6 in A? Yes. 12 in A? Yes. 18 in A? Yes. Does it matter that A has extra? No. C is a subset of A. That's true. C is not a subset of B. In order for that to be true, everything in C can't be in B. 6. The moment that one of these is not in B, it's not a subset. Is 6 in B? No. So this is true. 12 also is, and so is 18, but it doesn't matter. As long as, even if one of those numbers is not found in the second one, it's not a subset. And the A prime is a subset of C prime. Remember, C prime is every number but that. So C prime, the complement of C, is 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 19. Do you want to list them? Is everything in the complement of A in C? Well, the complement of A is 1. Is it in C? Yes. 2. Is it in C? Yes. 4. Is it in C? Yes. 5. Is it in C? Yes. 7. Yes. 8. Yes. 10. Yes. 11. Yes. 13. Yes. 14. Yes. 16. Yes. 17. Yes. 19. Yes. However, the other way around, they're not in each other. You have no homework. Can you please put the workbooks back in the lockup?